Hello there, algebra friends. We are going to do a little bit of mixed factoring. Factoring completely is what it's called, which means we may have to factor several times within the same problem. This flow chart that you see on your notes and on the screen is supposed to help you figure out what to do when we're doing all this different kind of factoring all at once. So it says, look for and factor out a GCF. If there is a GCF, that's the first thing you want to see. Do they all have the common variable? Do they all have a common factor, number that can be divided into each coefficient? If so, we are going to factor that common factor out, divide it out, and rewrite our expression. With what's left over, after we take out the GCF, we look to see if we have two terms or if we have three terms. If we have two terms, we are supposed to determine whether the two terms that are there are perfect squares. If they are not perfect squares, then stop because you're done factoring. If they are perfect squares, then you just check to make sure there's a subtraction sign between your two perfect squares. If it's a plus sign between the two perfect squares, then you stop and it's not factorable. If there is a minus sign between your two perfect squares, then you factor it using the difference of perfect squares. After you factor out your GCF, if you have three terms instead of two, you try to see if we can find two numbers that multiply to be the last value and add to be the middle value. If we can find that pair of numbers, then factor it. If we can't, then it doesn't factor. All right, so let's do some examples. First thing we always check for is if there is a greatest common factor. Fast way to check, you look in front of the x squared. If it doesn't have a number there, that means the invisible number is 1. Factoring out a 1 never changes the problem, so we don't have to worry about it. That also tells us, if that's just a 1 in front of the x squared, that there will be no GCF with the numbers. So the other GCF possibility is they all have the same variable. Do all terms have the same variable? In other words, do each one of these different terms have the same letter? The answer is no. Okay, so there's no GCF. Next thing, when it's factoring a trinomial, we have the short way, we have the long way. The short way works when it's just 1 in front of the x squared. So the short way is just looking at what multiplies to be the last value of 9 and adds up to be the middle value, in this case, 6. What two numbers multiply to be 9 and add to be 6? So because it's a 1x squared, this is the fast factoring way. So it's x plus 3, x plus 3. If it's the fast factoring way, the factors that you found, the numbers that you found, are your factors. Those are the numbers that go right into the parentheses, and you're done. Okay, second example here. Look for a GCF. Is there a GCF between a 4 and a 25? The answer is no. All right, there's not a GCF. So we don't have to worry about it. So now we look at, do we have two terms or three terms? There are two terms. Are these both perfect squares? Yes. So I have two terms. They are both perfect squares. Yes. Is there a subtraction sign between them? No. So I stop because it does not factor. Okay, nice. Makes it easier. Third example, is there a GCF? Well, I know that between a 3 and a 9, I can divide out a 3. They both have an x, they both have a y, so we can pull out a GCF that includes all those pieces. A 3, an x, and a y. Now on the x, I have an x to the fourth and an x squared. The lower of those two values is x squared. So I'm actually going to factor out a 3x squared. On the y terms, I have a y to the second and a y to the first. The smaller of those two options is y to the first. So technically, I now divide each one of my original terms by 3x squared y. 3 divided by 3 cancels out. Subtract the exponents and subtract the exponents. Again, I'm going to divide by 3x squared y. Negative 9 divided by 3 is negative 3. X squareds cancel. Y's cancel. There we go. All right, fourth example. Is there a GCF? Nope. Okay. So then there's two terms. They're both perfect squares, subtraction in between. So these two terms are going to split perfectly. That's why it's called the difference subtraction of perfect squares. 144 splits into 12 to the fourth and 12 to the fourth. 25 splits into negative 5y and positive 5y. Sorry about that. And then the last example is what we did in the previous lesson. No common factor. So I'm going to multiply 2 times negative 9 and try to find two numbers that multiply to be negative 18, and the same two numbers have to add up to be negative 3. So what two numbers multiply to be negative 18 and add to be negative 3? That'd be negative 6 and positive 3. So what we do, if you remember correctly, we bring down the 2m squared. The 3m that was in the middle was created by the negative 6m plus 3m, the numbers that we just found, and then bring down the negative 9. Now it's just a matter of GCF with the groups. So group, and then factor out the greatest common factor. So for the first two, so just notice I accidentally wrote an X. I'm going to factor out a 2m, leaving me with m minus 3. Second group, I'm going to factor out a 3, leaving us with m minus 3. And remember, those parentheses are supposed to match. That's not coincidence. It's supposed to be that way. So my final result, my final two factors are m minus 3, and the other factor is the 2m and the plus 3. We take the pieces that were the GCF and make them into their own factor. All right, so I'm going to just do a couple more and bounce around a little bit with which examples we do together. But the three main types of factoring is greatest common factor. That's what you always do first. Difference of two perfect squares, or trinomial factoring. And that would also include the grouping. If the number in front of your x squared is bigger than 1, then we have a little bit more work to do. But no matter what, you always want to try to do a GCF first. Always try a GCF first. Always try a GCF first. So for example, number 1, I notice that these are all even numbers, so I can divide out a GCF of 2, leaving me with y squared plus 12y plus 8, plus 6y in the middle. Now, when it says factor completely, that means there may be more than one round of factoring that happens per question. So to factor this again, because it's just a 1 in front of our squared term, coefficient of 1 means it's the easy kind of trinomial factoring. So what two numbers multiply to be a positive 8, and the same two numbers add up to be a positive 6? So keep your GCF. Fast factoring way means the factors that you found that satisfy the given conditions are the factors that make up your answer. Next example, number 2. No common factor with the numbers because it's just 1x to the third, but they all have an x. So take an x away from each one of those terms. Then we do the multiple add thing. Multiply. So what two numbers multiply to be negative 54, and the same two numbers are supposed to add up to be negative 15. So check it out on your calculator. You're going to type in negative 54 divided by x. You're going to go to the table and figure out how can we make a negative 15 from two numbers that multiply to be negative 54. And we're dealing with whole numbers, so anytime you see a decimal, just skip it. These would add up to be negative 53. These would add up to be negative 25. These would add up to be negative 15. Wait a minute, I think that's what we need. Yeah, negative 15. So it was a positive 3 and a negative 18. So x plus 3, x minus 18. All right, turn the page. We're going to go to the next page and do this with some difference of perfect squares. So we'll do one or two of these. GCF first. So between a 16 and a 100. If you're not sure about the GCF, you go over to your calculator. You do menu, option 2 for numbers, option 5 for greatest common divisor. And the numbers we're looking here, or working with here, are 16 and 100. GCF is 4. Calculator takes care of that for you. So you need to be able to divide out a 4. 16 divided by 4 leaves you with 4. X squared stays the same. And 100 divided by 4, like $1 split into quarters, would be 25. Now remember, factoring completely means you are going to try to see if you can factor this several times. We already took out the GCF of 4, so that has to stay. And what's left is the difference of two perfect squares. 2x plus 5, 2x minus 5. Now we're done because there's no more x squareds. And 5 is not a perfect square. So there's nothing else we can do. If there is a GCF of not just numbers but also variables, just take it out. So these can both be divided by 5. They both have an x. Smallest exponent is x to the first. They both have a y. Smallest exponent is y squared. So now go ahead, do 180 divided by 5. Subtract the exponents on the variables. And the y squareds cancel right out. Next, negative 5 divided by 5, negative 1. I don't really need to write the 1, but it makes me feel good sometimes just seeing a number there. The x's cancel out and subtract the exponents. Now, what's left over in my parentheses is the difference of two perfect squares. So 36x to the fourth splits into 6x squared and 6x squared, while negative 1 y squared, or just y squared, splits into plus y minus y. All right, so each one of these are done similar to that. Let's take a look at number 12 and 13 at the bottom. Number 12 is similar to what you had on your checkpoint if you were around to take the checkpoint yesterday. But there were some issues, so let's go through how to do this. They're telling you that you have an expression x squared plus kx minus 6, and x minus 3 is one of the two possible factors. So that means when all is said and done, we have x minus 3 and x plus or minus some other number. Based on the type of factoring we've been doing, we know that we're looking for two numbers that multiply to be negative 6 and add up to be our unknown value of k. There's our negative 6. That's the multiplication number. There's k. That's our addition number. Well, because they gave us half the answers, we know one of the numbers that we're looking for is already a negative 3. So if we are looking for two numbers that multiply to be negative 6, but we already know one of them is a negative 3, well, that makes it pretty easy to find the other one as a positive 2. So there's our other factor, x plus 2. All right, last one on this page. Completely factor the expression 9x squared minus 6x plus 1 and write your answer in two different ways. How are we going to do this two different ways? Well, let's worry about that at the end. Okay, so this has a 9x squared, so our coefficient in front of the x squared is bigger than 1. That means we have to do the longer grouping method of factoring. So we have to multiply 9 times 1 and bring over our addition value of -6. So what two numbers multiply to be 9 and add up to be -6? Multiply to be a +9 and add to be -6. So it's -3 and -3. So that means I bring down the 9x squared, and the -6x that was in the middle came from -3x minus 3 more. So now you're going to group and GCF. Group, GCF. Now, remember that our two parentheses are supposed to end up the same. This is a -3 that has to turn into a +3x. And then the +1 needs to turn into a -1. So that means I am going to factor out a -1. So the common factor is 3x minus 1. And then the pieces that I factored out, 3x minus 1, show me that my two parentheses, my two factors, are actually the exact same thing. So the other way of writing this is writing it as one factor squared. All right, so we grouped and did a GCF. We grouped and did a GCF. The last type of possible factoring that you could see is if you have four terms. Now, don't let this freak you out. Don't get panicked. Take a deep breath because this is actually very easy. It's actually what we've already done. With the problem that we just finished, once we had the 9x squared minus 3x plus 1, we had four terms. We grouped and GCF'd. That's what you're going to do here. We don't have to figure out the numbers. It's actually easier. It's less work. We're just going to group and GCF. We're going to group and GCF. If what's there already matches what I'm supposed to have, then your GCF is just a 1. So you just use a 1. And then the common factor of x plus 2 gets combined with the GCFs to make your final answer. So that's all you do. You group and you GCF. And you group and you GCF. Then you take the one common factor, and then the GCF is your other factor. All right, so that's all I'm going to go through. I kept it under 20 minutes, but went through a lot of different things. Go back, do some practice problems, and then go hit up the answer key in Teams to make sure you're doing them correctly. Open up the answer key in Teams and make sure you're practicing these correctly. Go back and do the ones that we skipped and open up the answer key in Teams and make sure you're doing them correctly. Peace out. Be safe. Goodbye.